there, we're from Asker Upper Secondary School in Norway, and we're here to share our Earth observations. We have been tracking the Thwaites Glacier calving motion, and we've also discovered a rotating iceberg around the Brunt Glacier on Antarctica. We're starting with the Thwaites Glacier.
Our school is a member of IRIS, and we joined the Earth Observation Project to focus on environmental research, which is a part of our curriculum. We've used the QGIS 3.10 to analyze glaciers in Antarctica. With the help of satellite from ESA, who have the Earth observation satellites. And we have worked with satellite pictures of Thwaites Glacier, and we started by mapping pictures in QGIS, and then we made shapefiles to calculate the migration rate. After analyzing 2 pictures of Thwaites Glacier with 594 days apart, we discovered that the migration rate was 24 meters a day average, which is alarmingly fast for a glacier. The total migration after 594 days was around 211 kilometers.
We also watched this floating iceberg outside of the Brunt Glacier. The area of this iceberg is approximately 117 square kilometers, which is over 16,400 soccer fields. We can also assume it is between 100 and 150 meters thick. It floats by the Brunt Glacier at an incredible speed at a rate at around 1 meter per hour. On this video, it moves 265 kilometers over 108 days. But what interested us the most about this iceberg was that it rotated in addition to moving quickly. Through these 108 days, it rotates at least 2 rounds, as we can see on this video. The really interesting part about all of this was that it seemed like it started rotating the other way around. This video is put together by 10 pictures with about 12 days in between each photo. So we don't know for sure if it changed its rotation entirely or if it started spinning incredibly fast and in reality rotated an entire round. To be able to stop an iceberg of this size from rotating and in addition making it start spinning the other way around, incredible amounts of energy are needed, and it's hard to see how that could have happened in the middle of the ocean. The other alternative is that it could start spinning a lot quicker, and that way it could have rotated almost 2 rounds in a short interval of time. Either way, a large amount of energy is needed to make this iceberg rotate at all, considering how incredibly massive it is. So we have a couple of hypotheses as to how this could have happened.
As said, our images are taken every 12th day. We measured the angle of on each picture to see the direction of rotation and the angular velocity of the iceberg. From the analysis of the pictures, we established 2 hypotheses. One is that the iceberg is rotating both clockwise and counterclockwise. The other is that the iceberg is rotating only one direction with varying speed. We have looked at many factors that may or may not contribute to the rotating behavior. One is wind. We looked at historical weather data from Null School, a weather database that is based on the global forecast system. We found that the wind at the time could contribute to the rotating movement of the iceberg. However, the mass of the iceberg could be too big to be moved by the wind alone. Therefore, we took a look at the ocean gyre. The iceberg is moved by the ocean gyre, but we are not finished with the study of local currents as a contributing factor to the rotating iceberg. This will be further researched and presented in our upcoming poster.
Yeah, as you said, our research is not yet complete and we have a lot left to look into. For example, we've discovered that the D21B iceberg, the rotating iceberg, is still popping up in satellite images post-2019. It was last seen north of Antarctica on April 16, 2021, which is only a few days ago. And it appears to have followed the Weddell Gyre currents up and away from Antarctica. We will look further into this phenomena, the rotation, how it happened, and we will also look at the alarmingly fast migration rate of the Thwaites glacier, the history behind the glacier, and how deep warm water will cause huge global consequences for us all. Look forward to that on our poster. Thank you.